So, Adam, the stage is yours.
Oh, perfect. The questions, actually, you can ask whenever you like. You don't have to wait because Matthäus said he will read the questions with a delay. So welcome to vaConf. So this is the conference which is completely wrongly spelled, right? This should be with J, but it's also okay. This is Java. And yeah, the cloudy patterns is some ideas, what I do in projects. And if I mention the ideas in projects or Java user groups or conferences, people are surprised. There's actually something like this is working well. So let's start. So this is if you use the QR code, you will find basically a website with links. So as Matthäus said, I even have a website. So this website points to GitHub, Twitter, Blue Sky, and Discord channel. This is basically it. It's just a collection of links. So I like really Java. I use Java all the time. Currently in all my projects, Java 21. I think there's no more Java 17 or 11 projects, or Java 21 everywhere. I use Java 17, then skipped everything to Java 21. And there's a podcast, the airhacks FM. So now we're covering various stuff from Kubernetes to serverless. It's just fun. So I invite people and to talk about various things. And if you have any questions left, there is a airhacks TV first Monday of the month. I'm answering questions where you can ask on a GitHub gist or in Discord or Twitter. Ping me, and I will try to discuss the topic you are interested in. That's the deal. So okay, and the cool story is there's a daily shorts in Java. So if you go to my short channel, you will find 30 seconds between 60 or 30 and 60 seconds. Java code snippets where I get inspired in my projects, and then I post daily shorts. So it's just fun, actually. Okay, there's the Discord channel if you're interested. And now, yeah, forgot about that. So there's the I also give from time to time workshops, and they are right now AWS, but I think next year I will also do some Java 21 and microprofile stuff just without clouds. Okay. So I actually started Java in 1995. And we had to build everything from scratch. So this is why it was true DevOps. And yeah, and now the first slide with content. What's interesting is that Java is actually very well suited for the cloud. So I have this slide on all my presentations because people still are stunned that this is the case. This is like a study from Google. Google was one of the participators, but you can download a study. And what you see is that Java is number 5 according to energy consumption. So right ahead Ada, it is even better than Swift, Go, and C#, the other languages, which is interesting. And what's even more interesting, that Java is 35 times better than JRuby or Ruby or Python, and way better than Perl. So and the same is true for the performance, actually. So you see, this is the energy consumption, and this is the performance. And this is a little bit more interesting because if something is fast, it is usually cheap in the cloud. So Java is not, it's actually, it's doing really great. So there's the first is C is the fastest, than Rust, C++, Ada, and Java. And where Java does not that well is memory consumption. So for instance, Pascal, interestingly, is 6 times better than Java. So if you would like to save memory in the cloud, so just have to use Pascal, Turbo Pascal maybe. No, just kidding. It doesn't actually matter for serverless because you will see in a second, you have to buy with RAM CPUs. So to have one CPU, you have to go with 1769 RAM on Lambda to have one CPU. So, and if you run Quarkus, which I will do in a second, you get you can run Quarkus with 80 megs of RAM. So you have plenty of spare RAM in the cloud, actually. So money talks. What does it mean? Motivation of the talk is the following. So what this is the calculator, the AWS calculator. Of what you see is 2 transactions per second entire month, 2 GB of RAM. So a little bit more than one CPU, and you will pay it 15 euro a month. So this is, you say, okay, two transactions per second is not much, but this is day and night the entire month. So, and this is a plenty for, I think, even for a startup, because startup would, I think it will have no peaks. If something happens, you have lots of traffic and then you have no traffic. So it will average over the month. But particularly interesting for enterprise applications, where I spent my time, is this, because what this means is that most of the enterprise projects can basically run for free because they don't have 2 transactions per second. Okay, now the first pattern, or let's compare it to EC2 machine. What this is like the Graviton recent machine with 8 gigs of RAM and 2 CPUs, and you will pay roughly $30 a month, $35 a month. An Intel machine would be even more expensive. And so there is a $15 versus $35. But what you have to consider, you cannot run the machine without VPC. So you will have to pay for IP addresses. You will have to pay for the VPC, for the NAT gateways and load balancer. And actually, you will need at least 2 machines, if not 3. So to have a small microservice running, you will have to pay 70 euros plus load balancer is roughly 40 euros. So it will be 110 to 150 euros a month for basically nothing for 2 CPUs, because we only need 2 machines for failover. And failover is built in Lambda, so this has motivation. So what I see in real world projects is that actually the projects are, for a simple microservice, they are paying several hundred euros actually to run on not even on a single CPU. As always, ask questions and Matthias will interrupt me and ask me. So the first pattern is ARM first. So if you run Java on the cloud, it actually doesn't matter. ARM works well whether using EC2 or Lambda. If you can prefer ARM, and it is cheaper and faster and more energy efficient than Intel usually. So if possible, just pick ARM. So this is the first small pattern. Okay, now let's take a look whether where serverless makes sense and where it doesn't. So if you have web scale applications, it's like TikTok or YouTube or vaConf, where millions of people are connecting and watching simultaneously, right? Then maybe serverless becomes more expensive than bare metal. Maybe it becomes, because there is an overhead you have to pay, or overhead. There is some additional services you are buying with serverless, and you have actually pay for it. So, so what it means is Lambda or the heavy load will be 20-30% more expensive than EC2 machine under heavy load. The problem is, how to have a load which, let's say, which runs on a EC2 machine and utilizes the machine to 80% and uses 80% of the CPU the entire time. This is the mission impossible here. So, so it means for web scale applications with unpredictable loads, fast scaling, and so forth, maybe it is interesting for scaling, but maybe it is not the cheapest option. Whereby, if you have boring enterprise applications, I think serverless is the way to go, because you will pay almost nothing, and it's even more secure because you don't have to care about infrastructure, operating system, patches, and stuff like that. Matthias, what's going on? Are there any questions in the chat, or is your audience lazy, or is there anyone listening except you and the technician Patrick?
I believe that we are just starting, so no questions.
No questions. Everyone has breakfast, so I'm talking, to no one here. So serverless first. What serverless first means? I think you should start with serverless. Not I think. This is the logical way to go. Why that? So if you're on premise, you have complete control over your machines. So you can actually optimize the machines, care about the machines. You are, the master of machines. But if you go to the cloud, the question is why you are going to the cloud. And I don't think you still like to, fiddle with the machines, right? So what I sometimes hear from developers, they say, I don't care about, where my application is running. I only would like to have a Docker container or EC2 machine a virtual image, right? So an image, and I'm happy. But in this particular case, why are you going to the cloud? You're not using anything of the cloud, and it's probably going to be even more expensive than on-premise. So I would say if you go to the cloud, use the cloud and use the features of the cloud. And one feature of the cloud would be, if you're on-premise, you have to care about super Docker images, Java installations, certificates, certificate rotation, operating system, and patching. If I go to the cloud, I would like to improve my situation. And then I would say, I'm not doing this anymore. I'm just focused on business logic, and then push, the business logic to the cloud. And this is what I would actually prefer. So if I go to the cloud, I use the cloud, and only if it's impossible to do that, then think about alternatives, like running your own cluster or running Docker containers or whatever. So to explain you serverless in 1999 and later, so we had Apache HTTP server. I don't know whether you remember. It's an old server. Matthias, you know HTTP server? Apache.
Of course.
Of course. So you are too young to know it, but I think he's lying. But I believe that it is an Apache HTTP server. And why the name Apache? Because it was Apached a lot. This is the you know now the secret behind Apache. But the point was, to run the Apache, you had to install a plugin, modjk, proxy, and so forth. And this plugin was responsible to listen to the path, to the URIs. And in particular, URI, it just forwarded the requests to application server. So this was the architecture back then. And you can consider the data as event. So the Apache created events and sent the events via proprietary protocol to the backend application servers. Now, AWS Lambda is actually the same. So we have HTTP API gateway, we can have REST API gateway, application load balancer, VPC lattice, function URL, and this how to call it, not web servers, gateways are listening all the time for HTTP requests, and they are configured. This is called usually proxy integration, that on all requests, the requests are forwarded to Lambda runtime. And what I show you today, the Lambda runtime wakes up, invokes my own old enterprise applications. So funny fact or interesting fact, the application here and the application here are identical. There is no change in source code. What only changes is the runtime. Okay, so what it means for serverless in enterprise, you will see in a second. So we can basically scale to 0, means no traffic, no costs. And we also get for free A/B deployment and rolling updates. Okay, infrastructure as code with Java. The first pattern, real pattern, and to show you how this works is I need a terminal. So in my terminal with Java, written correctly, I would like to create a CDK AWS project. This CDK project you will find on my GitHub account. What happens here, it just clones the GitHub repository and infrastructure as code J. So, and what happened now is it created or cloned the Maven project. It's just stock Maven with prepared main method. And what I'm using here, a CDK Cloud Development Kit from AWS, because I push to AWS. If I would use Azure, I would use Bicep, for instance. So now the CDA stack. So what I can do here, I can code the infrastructure. So let's say something simple, just go and create a log group. So log group builder create. I have to use the scope. What I also have to use is the ID, and this is going to be vaConf. And then let's say the group name, log group name, and it is Java. I have to be careful how to spell Java correctly, and build. Now the cool story is you can say, okay, now what? But the interesting part is log group. The interesting part is, so if I had here something else, like say Lambda, I could actually tell and say log group grant write, and I could actually set the permissions here so that my serverless Lambda already is allowed to write to the group. So I can code not only the infrastructure, I can stick the infrastructure together and the permissions are created for me behind the scenes. So if I run the code here, build and deploy, don't ask, and you don't asking any questions because you are in the breakfast. But if your breakfast is done, you see this session and you will ask questions. Then the first question is, what happens in the build and deploy don't ask? And my answer is actually nothing. So if you take a look what happens here, it is the clean and package and CDK deploy. This is what happens. So first the infrastructure is built and then deployed. Now, so it happened. So, and what I can do is I can go here and say, and ask for the log group. As you can see, the Java log group is created, and I should be able to see that in CloudWatch logs. As you see, this is the CloudWatch log group, but there's nothing there. But what I did right now, I created on the fly a log group. I coded that, and of course, if I change the name and rebuild this vaConf. Let's say this is Java, like that. And if I rerun the code, it will decide whether the log group can be renamed. And this is interesting. I never tried actually to rename the log group. Maybe it will create another one if not possible, but something will happen. But what happens is up to the cloud. The entire state is stored in the cloud. So let's see. And see what happened. So you reload it. And there, oh, this is what I suspected. So there is the new one is Java and Java because it was, it is sometimes if you're dealing with tables or S3 buckets, it is too dangerous to delete the stuff. So it created just another log group and referred to that. So I could use it and I will have to delete it manually afterwards. Okay, so first pattern done. Infrastructure, code the infrastructure. So next pattern is development in production. So what you saw right now is I just coded the log group and it was pushed to my account. So now account is just a number. So what it means is I can actually in serverless have identical environment. My development environment can be identical to production. And the question is why only in serverless? And the answer is because serverless costs you nothing. No traffic, no costs. For most cases. So for AWS Lambda, for DynamoDB, for S3, for SNS, SQS, for this base services, no traffic, no costs. And yeah, this is actually a big deal. So what it means in my projects, every developer gets an own AWS account. And the accounts, is working the account, and the production account is just another account which is provisioned by CI/CD pipeline. Okay. Big monolithic function. So first we coded a little bit CDK, and now I would like to talk a little bit more about no abstractions. So and what I hear a lot is multi-cloud environments, right? So companies try to say, okay, I would like to push to AWS or Azure, and they build abstraction layers and frameworks. From my perspective, it is problematic because I don't know whether you have some Java experience, but in the entire history of Java, we always had or always wanted to abstract from things, and it actually never worked out. So there are huge frameworks and projects and abstractions layers and indirections, and at the end of the day, it was pointless. And similar is in the cloud. I think you have two possibilities. One possibility in the cloud is to try to abstract from everything, and then you are portable. But you will write a lot of code and lots of abstractions. And what I tend to do is just no abstractions, write simple code. And if we have migrate between cloud, we only have to migrate the simple code. Okay, self-provision project. So this is the real pattern here. And now call here setup CDK. Setup Quarkus. Lambda with CDK AWS project, and I would like to call it Java service. Java service. What happens now? Self-provision projects means I have here now two projects created. So the first one, it looks like Quarkus, or it doesn't look like Quarkus. It is actually Quarkus. I can actually run it. So if I go to the resource here and say go to greetings, and say hello Quarkus for Java and run it, and it should work. So it starts, and I can just access that via localhost curl localhost 8080/hello. You see Quarkus for Java. So this is just regular Quarkus. And I would just pick the regular Quarkus so I can run it, test it, debug locally without Docker containers, without anything. It's just a local installation. And but what I can do at the same time, I'm coding the infrastructure here, and how it looks like that. So I have here a function name. Let's call it Java on Lambda. Java on Lambda. And I can actually set the configuration. configuration, and then set a map with and I think the Java looks like that. So we have function name, Java on Lambda, configuration function URL builder. So, and with a little bit of luck, if I run the code here, is built and deployed on ask. So now it builds the Quarkus first, creates the function zip, which only contains code, and then deploys everything with the CDK to the cloud. And in this particular case, there's this, it actually runs, I think, on a half a CPU. I forgot to look up what's the RAM configuration. But the idea, what you saw here, this is, I call it self-provision project or runtime, because if we take a look, this is one Maven repository which comprises the infrastructure, the business logic, and the end-to-end tests. So everything is inside. So in a pipeline, you would build the infrastructure first, then deploy the business logic, and then run the tests, and then switch the environments. Okay, so now it deploys the Lambda. It takes roughly 1 minute, 2 minutes. Depends on the day and on the internet. And yeah.
Okay, Adam, I see one question on the chat.
Very good.
Pavel asked if we can run test it locally.
Yeah, I run the test locally. So we run everything locally. This is the interesting part, because so I run now. So the Quarkus is just a Quarkus. So now it was absolute cold start in 3 seconds. So in the subsequent start, you see is like below 100 milliseconds. And if I go, but this is the entire, so this, hey Java in the clouds. So this is the URI. And the performance is even better, because CloudWatch logs, this is the Lambda. So it started now in the cloud. This is my log file. You see Java 21, and it is the Quarkus, and the cold start was 2 seconds. But I would be charged for 300 milliseconds, and you see all the subsequent calls are 5 to 6 milliseconds. My origin calculation were 100 milliseconds, so we are way better. And this is a Quarkus full stack micro profile application, which has 1.7 gig of RAM, because 1 CPU, and the memory consumption are 200 megs. And so we always run it locally. So what you can do, you can start your Quarkus locally. Actually, it still runs locally. So this application runs in the cloud and locally. I think it still should run. So if I go to localhost, I have to start it first. I think I stopped that, but yeah, I stopped the Quarkus. So if I run in Quarkus in dev mode, it will start locally. And if I rerun the code here, you see it also answers locally. And so this is the cool part, actually, because if you have, let's say, DynamoDB or S3 or SNS SQS, you can keep it to have it in the cloud. And you can run your Quarkus locally, and it will connect to the cloud, and you can debug everything locally without any external tools. That's actually the cool stuff here. Okay.
Okay, and I have also another question for our audience. What gets deployed to the Lambda? Is it native Quarkus app?
No, I don't use native because it is not that serverless. What gets deployed? I'll show you this. The function.zip. So this Lambda is not native. You saw Java performance, Quarkus performance. With native, it would start faster even. It would be not 300 milliseconds, it would be maybe 50 milliseconds. And why I'm not using native images, if you think about this, in this particular case, the infrastructure, it is Lambda, Quarkus Lambda. I only have to tell Java 21. And you see, I can choose between ARM and Intel. I usually choose ARM, except for Snap Start. It's not even Snap Start. It's not crack. It is just a stock JVM. Java 21. So I'm not shipping Java 21. I'm just telling AWS, please use Java 21. And the cool part is AWS patches Java 21 for me. If I would build a native image, I'm in charge of building the image. I have to build, update, and patch the image, so it is less serverless than this approach. So I'm usually not running native images in production in the cloud. For serverless, on-premise, in private clouds on OpenShift or Rancher or Kubernetes installations on private clouds, we always use native images to reduce the memory consumption. Any other questions, Matthias?
For this time, I don't see any other question on the chat.
But they were good questions, actually. So, let's see, and you will stop me if the time is out, because I forgot, actually. So, when we started. So, self-provisioned projects. So what you saw now is actually, I call it a monolithic Lambda. Why that? This Lambda here has multiple endpoints. So I created actually 2, but they can be hundreds. So there is a time endpoint, and there is a hello endpoint. So what you saw was the hello, but there's also a time. So you can have as many endpoints as you like. So what it means is the Lambda here is only a replacement of a microservice which runs on Docker. And there's actually no impact on performance. You can have as many classes as you like. So Java is pretty cool with it. What should be a little bit careful with large dependencies. So you should not, put all the frameworks to the Lambda. But if you can write as many classes as you like as a business logic. So I couldn't find, any measurable difference. And the Quarkus optimizes it for you. So it removes, or it doesn't start the classes which are not used. What Quarkus does is a kind of tree shaking. And also what Quarkus does, it eliminates reflection, which is good for startup times. This is why it is so fast. And the cool story is, again, I can use my old Java E code and micro profile. There are no changes. So you don't have to change the code. You can just pick your application. Also good for migrations. Also interesting for migrations. So now, but what you can also do, you can have a Pojo Lambdas, and the Pojo Lambdas look like that. For instance, yesterday in the security workshop, we talk about exactly this Lambda. What this Lambda does, it would be invoked by HTTP API gateway and decide whether the request is authorized or not. So if the Lambda returns here true, then it's successful. If it's false, it's not successful. And this is the complete Lambda. So what's only missing is a bit of business logic, if else statement here, but this is that's all. There's nothing else to add. So this is use the Java record, the Lambda, and it is working. So I would say, compare it with Node.js and Python, I would say it is shorter than this, right? So so Serverless Archive, this is a big deal. So this is, we had EARS, now we have SARS. So what Serverless Archive is, I actually have it already. A Serverless Archive, what it is this is just a Maven project with as many Lambdas you like. So you have one zip with 50 Lambdas, and you ship everything at once. And this zip is installed over and again with different Lambdas. Why that? Because, what I would like to have is atomic deployments. I test everything at once, everything makes sense, I ship it once, and then it either it happens or it doesn't. Okay. Next one is app as a function. So we saw it already. So we are misusing the function as a HTTP gateway, I would say, as a microservice. And or we are misusing Lambda runtime to have cheap and scalable deployments. This is what happens behind the scenes. So my final thoughts is, if you go to the cloud, just use the cloud and not try to I don't know, abstract from the cloud and run virtual machine images or Docker containers and don't use any services of the cloud. There are some resources. What's interesting is the entire Lambda and serverless, it is extremely similar to application servers. So if you know a little bit application servers, you are the serverless guru. I promise you that. Actually, I had some sessions about that, and also will deliver some sessions in the future, because if you know EJBs or the scopes and you compare it to Lambdas, it's very similar technology. And yeah, So, and these are the project I used today. So I used the CDK plane. This was the first one. And then AWS Quarkus Lambda CDK plane was the other one. And we had no time for other projects, but usually we code a bit more. Okay, so if you like, we can see in my workshops. And other than that, this is the very last slide. And I think we finish on time, Matthias. We are perfect, right?
That's right, we are perfect. So we probably managed with a Q&A session very short. And I still one question for you. Could you comment on the serverless aspect in the context of Amazon's statement, where they mentioned that serverless was a big mistake for them, and by moving away from it, they achieved a 90% cost reduction?
Yeah, I already mentioned this. What you refer to is not Amazon statement. This is a department from Amazon Prime Video, I think, or Prime. This is just a department. And what I suspect what happened is they use serverless for high traffic load, and this was just too expensive. What I can tell you is in my enterprise boring applications, we are not developing Prime. So I have to admit, I'm not building Facebooks, YouTubes, or Amazon Primes. So my projects are more boring. So it's like, a database and a microservice. And for that projects, the serverless, we pay nothing. So these are huge cost savings. But what also happens, usually I have on my slide cost-driven architecture. There's one slide, cost-driven architecture. So we start the journey with the AWS calculator. And I also showed you the calculations. And if you do the calculation up front, it will cost what it costs. I mean, it would not change. But what I think, or no, what I know, lots of projects are doing, they go to the cloud and hope it is cheap, and they never measure. So this is a big mistake. And the Amazon case, I think to be cost effective, you have two strategies in the cloud. Bare metal is the cheapest one. Buy EC2 machine and rent it for 3 years in advance. So you get 70% discount. This is the best option you have. But you have to care about the machine for 3 years. So it costs you manpower. For serverless, you don't have to care about that, but there is no that great discount, and you pay a little bit more. And these are the choices. But the point of the presentation is, if you go to the cloud, you should consider serverless first, because this is a huge advantage. And if it doesn't work for you, then you have the reason to pick something different. So this is the summary of the talk.